All right, everybody, welcome to this webinar. So this webinar is how we can apply AI in the industrial applications. So this webinar series has 3 webinars. Today going to be the first one. What are the necessary steps to become successful in the AI applications? And then next one will be March 20th. Going to have Grima talk about the successful industrial AI use cases. And this one you can hear what are people doing with AI, and you may learn something from their use cases. And number 3 webinar will be how we can operationalize AI models for the industrial applications. I heard many people said they can do modeling simulation, but how you can get the models out of the simulation environment and put it on the either PLC, on the CPU, GPU, or the other embedded devices. So those are 3 webinars we're going to have starting from today until March. So today is Mil Sastry, our Senior Application Engineer, going to go over the first one. So before we start this webinar, let me talk about the webinar logistics. So total webinar going to have about 45 minutes presentation. And after the presentation, we're going to have about 15 minutes to have a live Q&A. So everybody will be on mute for this presentation. But if you have any questions, feel free to put the question on the presentation. You can put on a Q&A window. For questions on any other questions, put into a chat window. And also, we are going to make this presentation and video available after this event. So with this, I'm going to give this to Mil to start his presentation. Mil, I'm going to unshare from my side. You can start from your side.
Wonderful. Thank you so much, Angli, and welcome everyone. My name is Mil Shastri. I'm a senior application engineer at MathWorks. I've been at MathWorks for about 5 years, and today we'll be talking about how you can use MATLAB and Simulink to develop and deploy industrial AI applications in some really simple and easy steps. In today's session, we'll cover 4 easy steps that you can follow to develop and operationalize these AI applications. Starting with data access and preparation, we'll see how MATLAB and Simulink make it really easy to access data from almost all commonly known data sources, including the cloud. And then we'll see how you can quickly prepare the data and start making meaningful algorithms. Next, we'll go into AI modeling solutions, where we'll see how you can build machine learning and deep learning models using the inbuilt tools to quickly graphically build accurate models or even programmatically control each of the parameters of the model. We'll also see how you can interoperate with open source AI models such as TensorFlow and PyTorch. Once we have the AI model, we'll see how you can simulate its interactions with your overall dynamic system and test out its performance. And finally, when you're happy with it, we'll see how you can quickly operationalize your model by deploying it to your asset, edge, or cloud. So in effect, there are 4 key steps to this AI-driven system design workflow. Now, considering each one of you are from a variety of industries and working on a variety of applications, your specific pathway when going through these steps will go through a very unique manner. Nonetheless, please reach back to us regarding your specific application, and we will help you achieve your AI objectives by getting you on the right track really early on. Now, having said that, we provide a host of examples for building AI solutions in a wide range of domains as well, as you can see here, and particularly with a focus on providing domain and industry-specific examples that are vertically aligned. We have a vast collateral of solved examples and applications that cover almost all areas of the industry. This is just a small subset. So again, please reach out to us and we can help accelerate your AI development. Also, as an example of how the industry leverages our tools and services, Hyundai Steel was able to improve how they worked with their data. With MATLAB, they were able to create a custom model for automatic labeling, and their prediction error went up to 85%, thanks to having higher quality data. And even though they had limited knowledge on image processing and deep learning, they could successfully adopt deep learning for their project. And with evaluation support from MathWorks, they could prototype their approach easily with limited time bound. Now that we have set the stage for this 4-part workflow, let's dive into the first step, which is data access and preparation. When training AI models, we are typically working with really large amounts of data, and often they don't fit within memory. So MATLAB has a very elegant way to work around this. These are ways that you can leverage your limited resources either on your physical desktops as well as leverage computational power on the cloud. So data stores and tall arrays are really powerful ways to work with out-of-memory data. Now, here's an example for images. In case you're working with images, Big Image gives you a flexibility to work with grids of images at different and multiple resolutions, like image pyramids. And the reason I bring this up, images up, is it's a very common scenario when training image-related AI models. But there are other data types as well. Now, in the past years, cloud-based data access has become vastly important in the industry. So let's look at some of the solutions we provide, not just on a desktop, but on the cloud as well. So on the database side, you can quickly access data from a variety of databases. Right? Either whether it's on-prem or cloud-based databases, we provide connectors. Same is the case with accessing data from remote data storage, such as AWS, Azure, or GCP. Here's an AWS example to access remote data, just like you'd be accessing local data with just 2 lines. So IAM read a single image or data stored to a folder. As soon as you move to remote data, just by these 2 additional lines, by setting your environment key and access, your reading functions remain exactly the same. Just point to the new location. Now, a variety of cloud data services such as AWS Redshift, DynamoDB, Azure Data Lake, Cosmos DB are supported. And numerous web-based data formats such as XML and JSON via native functions like JSON decode and XML read, all of these are supported. So if there are specific functions, data types that you're interested in, let us know. We can help you out. Also, to make sure that your processing and preparation happens really close to where your data resides, especially if you're working on the cloud, we provide MATLAB-based VMs on the cloud with preloaded MATLAB images via easy-to-use reference architectures. And all of these are hosted on GitHub as well. And we can provide links and show you how to do that. Now, when working with data, oftentimes you may not have actual data as well. So in many cases, you don't have actual data to capture extreme failure scenarios, especially for expensive and inline running equipment. And in such cases, you can always leverage these dynamic simulation models to generate synthesized data. So this above case is a multi-physics dynamic simulation of a hydraulic pump used in oil extraction. So let's look at an example in MATLAB also, how you can access and prepare data really quickly. So in this case, I have gone ahead and loaded some pump data from the slide that we saw earlier. So if we get a quick sense of it, you can notice here there's some pressure data, and there's some flow data and pressure data, a few seconds worth of it. Let's go ahead and just visualize it real quick so you get a sense. So you can see here, it's a few seconds of data all in chunks, and each of those chunks have a fault code. Now, to quickly process this in MATLAB, there are super easy no-code and low-code approaches. So to process data, there's a diagnostic feature designer app. This is a part of the predictive maintenance toolbox. You go ahead and load this data into session. So, and for the case of this demo, I'll use a smaller data set. Right, let's load it, specify the fault code as a condition indicator, import this. And you can see here on the right side, with this app, you can generate a large number of features. There are frequency domain, time domain. You can also do data pre-processing. But what I'm going to do is I'm just going to go through a shotgun approach, automatically generate features using this auto features capability. And you notice here we are generating about 174 time domain features and 6 frequency domain features. Right? If you had rotating machinery, the number of features being generated would increase further. So let's just go with this for now. Hit compute. I've enabled parallel computing. So now this app is extracting features from the raw signals that we have. You give it a few moments, collecting it, ranking the features as you can see here. And it's sorted all of these features by feature importance. You can see here. So oftentimes you want to pick, you can see we started with just 2 variables, the flow and pressure variable, but now we have generated so many additional features from it. Now you can automatically, once this feature is generated, you can either generate code for it through this export generate code button, or if you want to integrate it into your model-based design workflows as a Simulink block, you could use the generate features extraction Simulink block. Let's say I want to just use the top 5 features. You can see MATLAB automatically go in here. You can see MATLAB automatically generated this diagnostic features function. It takes raw data as input and generates code as the output, the features as the output. This is all automatically generated code. And it created a Simulink block, which takes the raw sensor signal, uses this feature extraction block to generate features that can now be sent into an AI model, right? So makes your processing super, super simple. Let's continue. So we saw, we completed the first step of this 4-part workflow, which was data access and preparation. Now let's move on to this next step. So let's say the real or synthetic data is now available and you've extracted all the useful features from this first step, and we're ready to dive into building AI models, which is our next step now. Now, supporting this theme of low code and no code workflows that we saw, there are also apps for modeling. So for deep learning in particular, we ship pre-built apps that help automate model training and provide visualizations for understanding and editing deep networks. Apps like classification learner or regression learner app automate these steps as well. And there's also a new experiment manager app that enables you to create a deep learning experiment to train networks under various initial conditions and compare the results. So in addition to apps, there are other features that speed up the algorithm as well. So you have direct access to many algorithms used for classification and prediction, right from regression to deep networks to clustering. There are a variety of pre-built models developed by the broader community that if you want to use, you can use as a starting point. And then examples are a great way that engineers learn to use algorithms, particularly reference examples, which are built for very specific engineering applications. And we provide hundreds of examples for building AI models. So let's look at some of these apps. So to train the Deep Network Designer app lets you build, visualize, and edit deep learning networks. So you can import, edit networks. You can drag and drop and create new connections, as you see here. You can very visually create these new connections. You can edit the properties of each of the layers. You can analyze the network to make sure that the architecture is defined correctly and detect any problems beforehand. And you can generate MATLAB code for building and training these networks as well. So after you finish designing the network, you can also export this to the workspace where you can save or train the network. And really composing the network by dragging and dropping could also accelerate the whole process, especially if it's the first time you're going through this exercise. Now, you can further import networks and network architectures from TensorFlow and Keras and from the ONNX model format as well. So here we're going to load a pre-trained network and edit them for transfer learning. So we picked the mobile net V2 as it's faster, has high accuracy with a smaller footprint. As we've seen before, you can drag and drop these layers and create connections to replace the old one. Go ahead and analyze the network, import some image data into it for classification, and select the augmentation options. Visualize the results. You can monitor the training as well. And you can then edit the training options like learning rate, validation frequency, and retrain the network if required. So you see here the training in progress, and you see a variety of plots of accuracy, loss, and validation metrics. And this app really enables you to train image classification networks that are imported or created in the apps. And for other types of data, you can always construct the network in Deep Network Designer. Now, once you've built your network, there are numerous network architectures and different data sets, and it's very natural to get overwhelmed on which is the best for you. So if you really wanted to run through all these experiments, be able to compare the results, there's an app for that that was recently released called the Experiment Manager app. And this Experiment Manager app, you can run multiple deep learning trainings. As you can see here, you can explore the hyperparameters, you can monitor the training in progress, define experiments, and all in all, keep track of your work. Right. Finally, once you've gone through your experiments, export the results to use later in reports and further analysis. Now, AI training can take a long time, especially with large amounts of data and complex models. And with our cloud support and third-party integrations, your team can move to training on the appropriate platform, be it on the GPU or public cloud or private cloud. And the point really is that a single model in MATLAB can be moved to the appropriate compute platform, and it saves an enormous amount of development time. Now, we also know that the broader deep learning community is incredibly active, and there are lots of new models coming out all the time. And because we support the importing models from TensorFlow, PyTorch via ONNX, you have access to all these models and can work with them within the MATLAB environment. And you also have TensorFlow importer and Caffe importers. Now, here's an example of how one of our customers, Mitsui Chemicals, took advantage of this interoperability between MATLAB and TensorFlow. So they had a model in TensorFlow, but had issues being able to deploy it onto an application for their end users. And to solve this, they imported the model from TensorFlow Keras into MATLAB, and then used their experience to build and deploy the application to the enterprise system. So let's reorient ourselves to the big picture. We have completed accessing and preparing data. We have now built and trained an AI model. Now, depending on the application, the AI model could be doing a variety of things. Maybe it's identifying faults in your manufactured components, perhaps through visual inspection, or it's identifying faults and fault locations in running machinery, or it could just be estimating the remaining useful life of operating equipment. And as an example, let's also see how we could do that in MATLAB. So you saw using the Diagnostic Feature Designer app, we were able to identify the top important features. Now, right from here, instead of going into Simulink, we could export these features directly into the Classification Learner app. Okay. And I'm going to export the top 5 features just for this use case. And the point being that there's a lot of low code and no code approaches built into MATLAB that highly encourage you to leverage. Let's pick the right response variable. I'm going to go with the default settings. And you can see here very quickly, we can train through a large number of models. So if I say, let's train all quick to train models, and let's run this, use parallel and run this, you can see MATLAB is going to go and train through all of these models. I've only picked a small subset, but you can see in parallel, all of these models are being trained. You can identify the best models, and now this model is ready to go into the next step, right? You can export this model and pass this on to our next step, which would be simulation and test. So in a sense, we've completed the first 2 steps, and we're going into the simulation and test space. So once an AI model is built, the AI model by itself, it may not generate useful results. So it would help to run this model as if it were integrated into your overall system. So you can test out various scenarios and see how using the trained model improves the overall performance metric that is important to you. So this is where we go into the simulation and test phase. And we can integrate such models for system level simulation and test. And to assist this integration of AI model into overall system, there are various AI model blocks available to import a variety of AI models into simulation. So like in this case, there's an LSTM block to load a trained model into your overall system simulation. For example, engineers can combine sensor fusion, control logic, system dynamics of the plant, and visualization components along with their AI models for simulating scenarios in which they can operate. This right here, this detector here is the trained AI model that's integrated with the overall system. So this example shows how a vehicle and lane detector works in self-car driving, but you can very well extend this concept to your own use case, such as fault detection, monitoring, visual inspection, whatever the use case be. For example, in this case, the trained AI-based fault detection model is simulated with the entire system of a triplex pump. So as you can see here, let's go right to you can see as real-time data comes in, this system is able to classify the faults within the system accurately. So whether you're identifying something like a blocked inlet issue or a sealed leak issue, all of these AI-based classifications can be done with an integrated system. Now, to see how easy it is to integrate these trained models into MATLAB, let's start off by loading some test data that we have to test our already trained AI model. And we define some inputs to the Simulink model, and we will load the trained models. So we simply open up the Simulink model. This is an open loop simulation. We will normalize the input data and then denormalize it after the model prediction is done. And here we're testing out a variety of models. You can focus your attention right on top, where we start off with an LSTM block and simply provide the location of the MAT file wherever that model is saved. And the rest of the blocks are different models doing the same predictions essentially. So I'm going to skip a little ahead. Then we will simulate the Simulink model from MATLAB using the sim command. So we can analyze the results, and we can see that all of these perform quite well. See here comparative, and we could also do a visualization of the results to understand the behavior better. right? Where we do a comparative analysis of a variety of models interacting with the system. So now you saw that we could run these models programmatically through Sim. You can also run Monte Carlo simulations and various scenarios through PowerSim. So to do that, you can offload a lot of the heavy lifting of running multiple scenarios to literally hundreds of workers on server or cloud-based machines using MATLAB parallel server. So we provide reference architectures to quickly fire up MATLAB parallel server on the most common cloud providers. And although you can speed up your parameter sweeps and Monte Carlo simulations, optimizations, and other tasks really easily by leveraging the parallel computing. If this is an area of interest to you, please reach out to us when we can help set that up. Now, as an example of how cloud-based resources can speed up your computations, here's a simulation that can be completed in about 2.8 minutes on the cloud when you're using an HPC cluster, while only 2% of it completes the same time on your desktop machine. These are really powerful capabilities that MATLAB and Simulink provide very easy access to and can be easily leveraged. It can be easily leveraged to really speed up your simulation and test. Okay. Now, moving on to this fourth step of deployment, we recognize that AI models are becoming very important in a wide range of applications. And each of these have really different deployment requirements, whether it's an ECU production or an edge system in a chemical plant or an enterprise-based system for a production plant or cloud-based streaming services. AI can reside in any part of these systems. So your AI models need to be able to deploy to any of these possibly. So we recognize that there are a variety of possibilities available. So depending on your end use case, you can start in MATLAB or import an open source model or integrate it with Simulink, and then through code generation pathways, deploy it either to the edge by C++ code generation, to GPUs using CUDA code generation, or to FPGAs as well. Now, when it comes to operationalizing your models and your analytics, we essentially provide a wide range of solutions, right? So you can start right here in this MATLAB space and be able to deploy this trained model either as an executable, as a Docker container. Maybe for some reason you're integrating with Excel, you can do that. Not just that, you can use compiler SDK to generate a Docker container microservice out of it, integrate it into Python. Or if you have cloud-based infrastructure, you can deploy this onto MATLAB production server as we saw earlier. So especially for the cloud-based services, there's a little more detail that I can go into. And as we also saw earlier, you can start in MATLAB and generate code-based solutions as well, like C++, HDL, PLC, CUDA code, all of them. So really, and this workflow is not just supported for MATLAB, but for Simulink-based workflows as well. Same solutions are available. So highly encourage you to leverage these possibilities. Now, if you're deploying to an enterprise infrastructure or server environments, you can deploy to using MATLAB production server. Your solution will continue to interact with your data, your streaming sources, your variety of databases, cloud stores, containers, wherever. But it exposes this functionality through a software agnostic manner to any downstream solution. So you could literally be on an edge device or in Java platform or in Python and consume the predictive capabilities of these AI models. Also, using MATLAB production server on cloud, you can integrate it with operational systems, and we provide reference architectures to deploy MATLAB production server either on your on-prem server as well on AWS and Azure really, really quickly. So let's go into MATLAB and see how you could quickly deploy with a simple example. And just to let you know, I'm going to go through this workflow really quickly. And in the third session of this three-part series, we'll go into more detail of what we see right now. So let's say hypothetically you started with a really simple function, right? We generated our AI model, and now we'd like to deploy this function. We'll call this my deployed function. For the simplicity, I'm saying that there are two inputs. It takes two inputs. It loads a trained model and runs a predict function on it. Really simple use case, right? So as you can see here, two inputs and generates an output. So to deploy this, you can deploy this as an executable using compiler. You can build an interface with other softwares using compiler SDK, like generate a Python or a .NET library, create a microservice out of it, host it on production server, generate readable C++ code, as well as deploy it as a web app, right? And all of these workflows are really, really simple to do. And today, I will only show you how simple the code is. To deploy this as an executable, there's a command line based approach as well. So it's just literally this one command, MCC. Or you can do this graphically. This generates the executable that you can run from command line. Alternatively, if you want to generate a Python package out of it, there's a single command to do this, compiler.build.python package. And you can see here, with that command, you can now share this royalty-free with 1, 10, a million users. None of them need any MATLAB licenses downstream. You can see here, when I run this from command line through Python, it generates the required output. Similarly, you can generate a Docker container microservice out of it. Simply 2 lines of code. And I know I'm going through this really, really quickly, but if you're interested in going into more detail about this, definitely join us for the third session in the series. Finally, to host it on the cloud, there's a simple command, compiler.build.production server archive, as well as to generate code. Let me open this up. There is an app to generate code. It's called the MATLAB Coder app. It's a part of the MATLAB Coder toolbox right here. But without going into the details of the app, this app enables you to automatically generate code. This is the code generation code that essentially finally runs this code gen command, which finally converts the MATLAB code into C++ code that can be deployed onto your edge device. Really neat workflows. So let's continue. Now, there are a variety of use cases where our customers have leveraged machine learning and deep learning infrastructure in their autonomous AI-based development workflow. So in this case, this is an autonomous machine development workflow. The engineers are spending a lot of time labeling and managing data, and this resulted in long development cycles. And the solution, cloud-based data infrastructure that automated labeling, it enabled searching of data sets, and they were able to leverage some of the pre-trained algorithms to really dramatically get some speed up results and scalability. You can see here, they were able to host their algorithms on cloud-based services such as AWS, and it integrated really well with third-party cloud-based data providers such as Databricks as well, and deploy this AI model using MATLAB and Simulink onto embedded code that lives in their machinery. So I know we covered a lot of content today, and I completely understand that we went through a complex number of steps really quickly. But please keep in mind that these steps are really, excuse me, these steps are really simple to achieve using MATLAB and Simulink. So we provide a lot of practical training courses, online training courses to learn AI and data science. There are a variety of on-ramps available. So there's machine learning on-ramp, deep learning on-ramp. All of these are freely available. There are other paid courses as well, like MATLAB for data processing, machine learning with MATLAB, deep learning with MATLAB. And we're also partnering with Coursera on practical data science with MATLAB specialization courses. Now, there are a variety of other very specific instructor-led courses available as well. So if you all are interested in any of these, please reach out to us. And I'll point you to the website as well towards the end as we reach the end of the session, so you can explore some of these resources as well. In addition to training, we also have the MathWorks consulting services. So you'll benefit from a really deep product knowledge and broad technical experience of MathWorks consulting with our MathWorks consultants. So they can help apply our proven best practices to your project. And really, if you have projects that are time critical or you need additional knowledge base, definitely leverage this team. Also, we see applications of AI with our software across multiple industries, right from aerospace and automotive to biotech, energy production, med devices, railway systems, and we incorporate feedback, learnings, and feature requests from customers in all of these industries. So by leveraging our tools, you benefit from the latest and greatest of what's happening in each of these industries. And we also see parallels amongst all of these industries. So internally, we share our learnings and make sure that you are benefiting from all of this common wealth of knowledge that we internally create. So with that, I'd like to conclude this session. I'll hand it back to Cheng Li. And please do register for the upcoming webinars. There's a QR code included here. You can scan it with your phone. There's also going to be a link provided in the chat. And I'll hand it back to Cheng Li, and let's look at some of the questions that may have come up in the chat.
Yeah, thank you, Mil. It's a good presentation. I saw several good questions in the chat window and the Q&A window. So let's, I try to answer some of them, but not able to answer every one of them. So we can maybe just go over them and answer them verbally. So if you still have questions, feel free to put a chat window. If you are not able to answer it today, we're certainly going to follow up with you after the event. So the first question, let me see. So this is from, if I pronounce the name correctly, Artem. Artem, he said, where to find the domain-specific examples? Are they part of the toolboxes? I guess very general question. There are lots of examples with the shipping examples. Yeah, we can show them how to find them. And also, Artem, what kind of domain you are looking for? So you can also get in touch with us if you want to talk about more in private setting. We can talk about your application case.
Absolutely.
Maybe you can drop this, maybe the link to the chat window. So
yes, I will. And I was speaking. I didn't realize it. I was on mute. So, so all I said was that in the MathWorks website, on the solutions page, it's classified as applications. And depending on the kind of application, so we're talking about AI today. If you go into AI, I'll put this in the chat window. And you can see a variety of use cases, as well as, depending on the area that you're interested in. You can go into whether it's deep learning or machine learning. You can go in there, and there is usually an application section and some tutorials and examples. So you should be able to find a variety of examples here. Secondly, also in MATLAB, if you search for your use case, so let's say YOLO or deep learning, whatever your use case is, right? So let's say YOLO V2, or we look at some object detection. You see there's documentation examples right here. And you can open this examples tab, pick an area that might be of interest to you. So let's say you are interested in this example, and say open live script. And with that, you should be able to run this directly from your MATLAB. Just keep in mind, depending on the use case and example, you'd need the specific toolboxes as well.
If you get a faster start, again, certainly reach out to us. We can try to work with you on your project. So that's good. Thanks, Mil. We can also maybe put those links in the chat window. So
yep.
Yeah. So the other question I see from here is it's from Ernesto. He said, "Oh, this is going too fast for him. He was looking for examples on the defect detection in images."
Great.
So yeah, I try to answer this in the chat window also. Next session, March 20th, we're going to have kind of a deep dive on several industrial use cases. Fault detection based on image will be one of them. If you want to know more right now, don't want to wait. I think Mil is kind of looking for some examples. You can go through our website to find more, or reach out to us. We can also follow up with you to talk about specifics. Okay, there's another question from earlier. Let me see, from Garrett. He's asking, do we have any pre-built examples for physics-informed neural network for CFD?
That's a great question, Garrett. I am not aware of physics informed for CFD. However, we can find out.
Yeah.
Yeah.
I did a quick search. There are a lot of examples on the physics-based informed neural network on our website, support website. On the CFD side, there are also many literature available in public domain from other users. They use MATLAB for those kind of applications. Yeah, so it's just based on several minutes quick search. There's so many information on our website, so that's why it's not find everything. But we can follow up. If you're talking about specifics, what you are looking for, maybe we can try to do something together. So that's another question from Abjit. He said, this presentation is very informative. That's good. Can you provide your thought on the system and memory requirement for using the diagnostic feature designer in the predictive maintenance toolbox for building complex models on large data set? So how much memory computation power we need to run those kind of feature diagnostic feature designer?
That's a great question, Abhijit. And that is a use case that we come across several times. And what I recommend to my customers when helping them build their predictive maintenance workflows using the diagnostic feature designer app is that the main goal is to predictive maintenance workflow is a very iterative process. So it's best to start working on generating features and exploring each of these features on a smaller data set. So as of now, the Diagnostic Feature Designer app does not take large data sets like tall arrays and things like that. So I recommend working on smaller data sets. But once you've proven that this workflow works well, the features are appropriate for a smaller representative data set, then expand it to a larger data set using the code generation capabilities. So that way you won't hit the memory requirements needed for when you're working with really large data sets. And that generated code will work for large data sets and out of memory data sets as well.
Yes, I think that's a good question. The diagnostic feature designer, the purpose to figure out which feature to use. That's why you go through all kind of possibilities, right? For this case, you don't want to use every data you have, right? Use a small amount of data and find out what kind of feature you need, and then based on that feature, you can use it on the large set of data. I think that's the idea. Yeah, it's a good question. So again,
and to add to that, Abhijit, if you have a use case that you need help with the DFT app, or even integrate with the results of the DFT into your AI-based workflow, feel free to reach out to us. We'll be more than happy. We provide this as a as complimentary service. So application engineering support, such as support from me for a few days or a few weeks, is complimentary. We can help you out with that too.
Yes. Again, if you have not registered for the next two webinars, feel free to, I also put a link in the chat window. You can register either on your phone, your computer. For next session, I'm going to focus on the industrial use cases, kind of more deep dive on what the other industries or companies have done, AI applications, how they become successful, or what are they? Maybe you can learn something from what they did, or you have something similar. So that's the next one. And then on the third one, we're going to come back to talk about how to operationalize your AI models. So if you don't put your model into the application, it's just simulation, right? That's why the third webinar is going to show how you can put those models into the different applications, including the cloud applications on the edge, devices or PLC, CPUs, GPUs. So those will be on the number 3 webinar. If you have a question, feel free to put it into the chat window so we can try to answer it now. There's another question regarding, I don't know if you saw it or not, regarding the annotated data. That is the input with the answers for training the model is some of the data classified as the edge case for advanced training of the model.
Regarding the annotated data that is input with the answers for training model, is some of the data classified as edge case? Oh, I see. Okay. It seems like I almost feel like this is like saving data for validation and test. And is that the question here? Like, do you save some data with answers as a test data set for this edge case validation? If that is the question, we absolutely do. Whenever we're going through an AI-based training and validation and test process, it has to essentially go through these 3 steps. So you train your model, and typically it would be something like you train your model on 80% of the data, validated on 10% that the model hasn't seen, and then iteratively do that till you finally be able to test it out on 10% of the remaining data set that has never been seen. And ideally, the training data should have all those edge cases as well that are representative of the validation and test, really to be true to real world scenarios.
Yeah, hope this answered your question. If not, feel free to put your clarifications in the chat window so we know what you are asking. So that's the question I see from the chat window and the Q&A window. Okay. So maybe Miu, you can also talk about if you have a Python model, are you able to incorporate this into the overall MATLAB Simulink workflow?
Yeah, absolutely. That's a great question. So
that's a question people always ask, right?
yeah, exactly. So MATLAB and Python work really well together. Now you can not just import TensorFlow and Keras and ONNX models into MATLAB, but you can also run Python scripts in MATLAB. So if I take a quick example here, you could run py.math. Let's see, square root, or let's see, square root function. And this right here is running the Python version of square root function, not the MATLAB square root, right? So in a sense, if you have existing scripts in Python, you can always pull them into the MATLAB workflow, right? Not just that, let me see if I have an example here. Now, you can also import your own Python scripts. So let's say you have this predict function in Python. Notice here, this is Python script. It's running on scikit. It imports some models on scikit-learn. This is a very simple example using some linear regression, and you run a predict function on 3 values. Now you could, this function is called my scikit-learn function. So you could do py.myScikit-learn, if I get the FCL. You could predict, right? You could be running your own scripts with your own custom libraries like this in MATLAB as well. So you can see here, we provided some inputs and it went in and ran the Python predict function that you had custom built using a NumPy array and a linear regression model. So you can definitely integrate. There are multiple ways to integrate MATLAB and Python. So, and if this is an area that you are interested in, again, reach out to us. We have multiple workflows to integrate MATLAB and Python together. And just like we pulled in Python and MATLAB, you can call MATLAB and Python as well.
Yeah, very good. Yeah, always good to see how those two can work together. The other question is on deploying the AI models, algorithms on the through production server. Are there any reference architecture how you can do it?
Yes. Yes. So for those who are interested in what we saw here, let's go on. For those who are interested in, go back, apologize. Those who are interested in hosting their algorithms on MATLAB production server, so they can operationalize it on the cloud, we do have reference architectures available. They are on GitHub. So if I GitHub network, oh, sorry. So we have a page on GitHub, and we provide a variety of reference architectures as well as for specific to deep learning. So if I go into the production server, you see here there's production server on AWS, production server on Azure. There's also production server on GCP. So let's say you trained your model and now you want to operationalize it by hosting it on the cloud. You can quickly come here, select the version you're interested in, and then hit launch stack. That's really it. And then you set up with this launch stack button, it'll open up AWS with one page where you set up your machine requirements and size. And within a few minutes, your system is up and ready with all the runtimes and production server deployed onto multiple workers as a production level system ready to be queried by any third party tool. So really, highly encourage you to leverage this. And if you need help with that, please reach out to us. We'll be more than happy to do this. We've done this with hundreds of customers, and we can speed up your work.
And also on our third webinar, we're going to talk more about this deployment option. So you can also make sure you register if you want to know more about deployment of your AI models for the real applications. Okay, that's all I see from the chat window and the Q&A window. Okay. So just a couple more minutes. Again, if you have not registered for the next 2 sessions, remember to register, and will be really interesting to see all the successful industrial use cases in AI, and also how to operationalize those AI models for your specific applications. So this will be really interesting to see. If there's no other questions, so we can finish today's presentation.
I see one question by Christian sent to me. Is there standard deviation for each answer with the training data? There's a lot of, so with the training data and the models being generated, there's confidence intervals, there's standard deviation, there are all sorts of parameters that you can access from the model. So if you want, at the end of the session or later on, please reach out to us and I'll help you find the exact right functionality. So back to you, Chengli.
Okay. Actually, there's another quick question from Siddharth. Is there some examples on driving pattern detection based on vehicle subsystem performance data set? There are lots of autonomous driving examples on our website. Since don't have, I don't know if we can do a quick search. If not, we can maybe follow up with you. Yeah, just go to the website. Yeah. So this should have a lot of pattern recognition.
Yeah, I highly leverage going and checking this out. There are lots of examples in here. You might find your answer there, and if not, we can follow up with very specific information for you.
Yes, it always help to talk about what you have in mind, because each application is unique. That's why it's good to know more about your details. So, all right, I think we are at the hour. Thank you for everybody attending this webinar session. So we're going to see you in several weeks later.
It's a pleasure meeting everyone. Thank you, everyone.
Okay, thank you, everybody. Bye-bye.